I am presenting here the interpretation of IR spectroscopy, which is useful for B.Pharm 7th semester in Instrumental Methods of Analysis BP 701T subject and in Unit 2nd. These are the functional groups and their absorptions like alkanes, CH bond and absorptions frequency range in 2850 to 2970 centimeter inverse, and it gives the strong intensity peak, and which I already discussed in previous lectures, like applications of IR spectroscopy and alkenes, alkynes, aromatic rings, amines, aromatic and alkynes, amines and nitro compounds and their absorptions and intensity of peak. The IR spectroscopy by functional group, examples like alkanes, which is combination of carbon-carbon single bond and carbon CH bonds, which shows the various CC stretches and bends between 1360 to 1470 centimeter inverse in medium intensity peak, and second one is carbon-carbon bond between methylene carbon in 1450 to 1470 centimeter inverse, and which shows the sp3 CH between 2800 to 3000 centimeter inverse. It is the examples like octane, which showing the alkanes and CC and CH bonds and their absorptions. Next example is alkenes, which shows the C single bond C carbon-carbon double bond stretch, which occurs at 1620 to 1680 centimeter inverse, and it becomes weaker as substitution increases. Vinyl CH stretch, which occurs at 3000 to 3100 centimeter inverse. This is the spectra of alkenes, like which showing the in this regions like 3082 and CH stretches and C double bond C stretches are there in 1600 to 20 to 1680 centimeter inverse. Next one is alkynes groups, and C triple bond C stretches occurs between 2100 to 2200 centimeter inverse, and CH for terminal alkynes, which occurs at 3200 to 3300 centimeters inverse in small intensity peak, and the remember internal alkynes like Cr triple bond Cr would not have this band, for example octane and their absorption. Fourth one is the aromatics, which due to the delocalization of electrons in the ring. The examples like benzene, which shows the resonance. The resonance is the shifting of an electron from one place to another place, and benzene molecule showing the highest resonance structures, and this property of benzenes and their ring, the stretches frequencies for the bond is slightly lower in energy than normal carbon-carbon double bond, and these bonds shows up as a pair of sharp band, and which gives the 1500 and 1600 centimeter inverse in small and medium intensity peak, and where the lower frequency band is stronger, and the CH bond of the ring, which shows the up similar to the vinyl carbon atom, and which absorptions like 3000 to 3100 centimeter inverse in medium intensity peak, for example like ethyl benzene, which showing this type of spectra. And specific groups like aromatics if the region between 1667 to 2000 centimeter inverse, like wide intensity peak, is free of interference, C Dolomont O stretches, and frequency is in this regions, a weak grouping of peaks is observed for aromatic systems, and analysis of this regions called the overturn of bending vibrations or bending regions, and can lead to a determination of the substitution pattern on the aromatic ring, which the region of this differentiate the ortho, meta and para directing substituents of the aromatic ring like benzenes, and their region is 1600 to 67 centimeter inverse to 2000 centimeter inverse, and they gives the following types of spectra. First one, which are showing the mono substituted benzene, and which giving the in this type of spectra, and another examples like 1,2 disubstituted ortho group, and which gives the in this type of spectra, and their bands are showing this type of spectra or peaks. And next example is 1,3 disubstituted or meta substituted benzene or aromatic compound, which showing or which shows the this type of peak. Third one is, and then last one like para 1,4 disubstituted benzene molecule or aromatic compound, which shows the in this type of peak. Ethers may be identified by a strong CO stretching band near 1100 centimeter inverse due to the COC linkage. Aromatic ethers which show a strong band near 1250 centimeters, while others are there. For example, the diisopropyl ether, and which showing the in this type of spectra or this type of peak. Alcohols which show a strong broad band for the OH stretches from 3200 to 3400 centimeter inverse, and small and broad peaks are there, and this is one of the most recognizable IR bands like ethers. So a band for CO stretch between 1050 to 1260 centimeter inverse, like and this band changes position depending on the substitutions of the alcohol, like primary alcohol when their absorptions in this region like 1075 to 1000 centimeter inverse, and in secondary alcohol and their absorption is 1075 to 1150 centimeter inverse, and in tertiary alcohol which shows the absorptions like 1100 to 1200 centimeter inverse, and in phenol which shows the 1180 to 1260 centimeter inverse. The shape is due to the presence of hydrogen bonding. For example, of spectra which is showing by 1-butanol, and it's which explain like OH stretches, COC and CO like OH stretches, which is showing in 3200 to 3400 centimeter inverse. Amines, primary amine, which shows the NH stretch for NH2 amide as a doublet between 3200 to 3500 centimeter inverse, and symmetric and anti-symmetric modes of their vibrations, and NH2 groups which shows a deformation band from 1590 to 1650 centimeter inverse in a wide peaks are there. NH in amines which showing the 3300 to 3500 centimeter inverse, and sharp, medium and intensity peaks are showing, for example 2-amino pentane, and their peaks are showing in this spectra. OH and NH bond, both OH and NH appears around 3300 centimeter inverse, but they look different. Alcoholic OH broad with rounded tip, and in secondary amine R2NH and broad with one sharp spike like peaks, and in primary amine RNH2 which shows the broad with two sharp spike peaks and no signal for a tertiary amine like R3N. Amines and in secondary amines like pyrrolidine in NH band for R2NH occurs at 3200 to 3500 centimeter inverse in medium and broad intensity peak as a single sharp peak weaker than OH stretchings. Tertiary amines R3N have no NH bond and will not have a band in these regions. And this spectra is showing the pyrrolidine aldehyde, which shows the C double bond O carbonyl stretch from 1720 to 1740 centimeter inverse and band is sensitive to conjugations. H are all carbonyl upcoming slide and also displays a highly unique sp2 CH stretch as doublet and 2722 and 2820 centimeter inverse called a Fermi doublet or Fermi resonance region is there. For example, cyclohexyl or carboxyaldehyde, which is showing this type of peak or and their spectra are there. Next example is ketones. The simplest of the carbonyl compound H for H IR spectrum. Carbonyl on the CO stretch occurs at 1705 to 1725 centimeter. C double bond O stretch as there, for example 3-methyl 2-pentanone and their spectra is showing this region 1705 to 1725 centimeter inverse. Next example is esters. Two regions are there. First one is the C double bond O stretch, which occurs at 1735 to 1750 centimeter inverse. And second one also displays a strong band of CO at higher frequency than ethers or alcohols at 1150 to 1250 centimeter inverse. For example, ethyl piavolate and their regions are showing in this spectra. Next example of carboxylic acid and which shows the two regions and C double bond O bands which occurs between 1700 to 1725 centimeter inverse and the highly dissociated OH bond has a broad band from 2400 to 3500 centimeter inverse and which covering up to a half of the IR spectrum in some cases, for example 4-vinyl butyric acid. Next example is acid anhydrides and their coupling of the anhydride through the ether which ether oxygen and split the carbonyl band into two with a separation of 70 centimeter inverse and bands are at 1740 to 1770 centimeter inverse and other peaks are 1810 to 1840 centimeter inverse and mixed mode CO stretch are there and their absorption is 1000 to 1100 centimeter inverse and for example the propionic anhydride and which gives the in this type of spectra. And next example is acid halide or RCOCl or acid halide which denominate bands at 1770 to 1820 centimeter inverse and for C double bond O and the bonds to halogens like chlorine, bromine and iodine which due to their size occurs at low frequencies where their presence are which should be used to reinforce rather than be used for diagnosis like CCl bond which is absorbed at 600 to 800 centimeter inverse and for example the propionyl chloride and their absorption which are showing this in this type of spectra and their regions are which is showing in 1770 centimeter inverse to 1820 centimeter inverse in CO stretches and other one is CCl bonds and 600 to 800 centimeter inverse. Next example is amide which displays the features of amine NH2 groups, and the carbonyl compound, the CO stretch occurs from 1640 to 1680 centimeter inverse. If the amide is primary, like RNH2 primary amine, if the NH stretches occurs from 3200 to 3500 centimeter as a doublets are there. If the amide is secondary and the NH stretch which occurs at 3200 to 3500 centimeter inverse as a sharp singlet is there, for example of pure amide, and their spectra are showing in this region. Next example is nitro group, like NO2 group, and the two bands are seen which is symmetric and asymmetric stretches are there, which I already explained in chapter 1 or part 1 IR spectroscopy, and their region is 1300 to 1380 centimeter inverse and 1500 to 1570 centimeter inverse, and this group is strong resonance withdrawing group and is itself vulnerable to resonance effect. For example, 2-nitropropanone and their spectra are showing in this type of regions and absorptions are there. 70 and next example is nitrile, like cyano or C-triple-bond-N group, and the principal group is the carbon nitrogen triple bond at 2100 to 2280 centimeter inverse, and this peak is usually much more intense than that of the alkyne due to the electronegativity difference between carbon and nitrogen atom. For example, propionitrile and their absorptions showing in this region like 2100 to 2280 centimeter inverse. Thank you.